Welcome to Spring LIB.
In this question, we need to determine the molarity of sulfuric acid when working with a 35.38 milliliters of sulfuric acid solution that reacts completely with 0.3545 grams of sodium carbonate. Now, when this reaction takes place, the question states that the sulfuric acid reacts completely with the sodium carbonate. So that means it takes place according to stoichiometry. So we will be able to use the stoichiometric ratio of the balanced reaction equation. And for that purpose, we just need to make sure that the equation is balanced. And according to what I can see, I've written down the equation, which is balanced as it is. You will see that I've put hydrogen carbonate in parentheses. Just I did that because it is unstable and usually or immediately decomposes into water and carbon dioxide. So I could have just as well written water and carbon dioxide there. Right, so the mole ratio for sulfuric acid to sodium carbonate is 1:1. I can already say that. Now, because I'm working with mole ratio here and I have to determine molarity, I'm going to calculate the number of moles of sodium carbonate first so that I can use this to determine the number of moles of sulfuric acid. And then it's easy to calculate the molarity because I already have the volume. So let's do the calculation step first, or the calculation of the number of moles of sodium carbonate. So the number of moles of sodium carbonate is going to be equal to the mass of sodium carbonate, which is 0.3545 grams, and if I divide that by the molar mass, I will get the number of moles. The molar mass of sodium carbonate I've pre-calculated as 106. So just here, let me just write down here. So the molar mass of sodium carbonate I've pre-calculated as 106.0 grams per mole. Right, so when I divide by molar mass here, I can just as well multiply by the reciprocal. So this is going to be 1 mole at the top and then 106.0 grams. So instead of saying divide by 106 grams per mole, I'm saying I'm multiplying by the reciprocal of that, which is 1 mole over 106 grams. Right, and then according to the mole ratio, the number of moles of sulfuric acid over the number of moles of sodium carbonate is 1/1, because the stoichiometric coefficients, as I've shown you in the equation for both these reactants, are 1. Right, so therefore I can say that the number of moles of sulfuric acid is actually the same as the number of moles of sodium carbonate, because I just need to multiply by 1. Therefore it's the same. And now I know that I have to determine molarity of sulfuric acid, and molarity is equal to moles per liter. Well, that's the unit of molarity. So I now need to take the number of moles of sulfuric acid divided by the volume of sulfuric acid. I already have explained how to calculate the number of moles of sulfuric acid, and that is by saying it's 1 times the mass of the sodium carbonate sample. So that's 0.3545 grams times the reciprocal of the molar mass, which is 1 mole over 106.0 grams. So this is the number of moles of sulfuric acid. And then I need to divide by the volume of the sulfuric acid. But the volume of the sulfuric acid is given in terms of milliliters, and I need a molarity unit of moles per liter. So I need to convert those milliliters to liters. So I'm going to say I divide by 0.03538 liters. And that will give me a final answer of 0.09453 molar. So let's just quickly recap what we needed to do to solve this question. I needed to calculate the molarity of sulfuric acid when this solution reacts completely with a certain mass of sodium carbonate. The volume of the sulfuric acid was given and the mass of the sodium carbonate. So fortunately, the reaction equation didn't need any balancing. It is balanced as it was set up. And then because I work with mole ratios in the end, I needed to convert the mass of sodium carbonate to the number of moles so that I can use this to determine the number of moles of sulfuric acid. And once I had the number of moles of sulfuric acid, I just needed to divide that by the volume of sulfuric acid in terms of liters to determine the molarity of sulfuric acid.